So this is part of what we're going to be talking about today is like you guys all signed up for is Freeware for Freelancers. I'm going to keep mine on this edit slide here. You've been looking at this. I just want to give a quick pitch to the AAPG Energy Minerals Division. I'm not going to read all this. You guys can do that in your own time. That's just the organization that some of us are affiliated with, and we thought that it would be best to move forward with a freeware talk to let everybody know about what's out there, kind of what's been tested and what's been used a lot. And that way you don't have to go through a lot of the aches and pains of figuring out what doesn't work and what does. Hopefully we can build on this with a users group later on, but this is just meant to be a sort of brief introduction. If you have questions, just post them in the chat. And also to kind of break down how today's going to work is I will be speaking for probably less than 10 minutes on Google. I'm then going to pass it to Marin, so it's out of order than what you're seeing here. She needs to head out of town, so she'll be talking about GIMP. What's that? Okay, she'll be talking about GIMP, which is a editing software, and then she'll hand it off to Justin. All of us three are going to be speaking for around 10 minutes. Then John and Matthew are going to speak for approximately a half hour each on QGIS and Python scripting. And then the final half hour will be open to questions. And again, post those into the chat window, and that way we can best address those as they come up. And each speaker will let you know if you want your question to be asked during their talk, or however they want to do it. The first thing I'm going to talk about is obviously I'm sort of moderating, trying to keep order the talks today, and I'll also going to touch on Google platforms, and that's something that a lot of you I'm sure are familiar with. If you're not, this is going to be kind of an eye-opener. You all are more than likely aware of Gmail. The Google platform, I kind of broke it out here into 3 pieces, and you can see my screen. That's my Google account in the upper right, and attached to that on the, where'd it go? If I go back, here are these there's a set of 9 buttons that says Google Apps. So once you sign up for your Google account or your Gmail account, you get access to all of these additional items in here. And if you haven't had a chance to actually dig in, it's highly recommended. This icon here is, of course, it says My Business, but that basically gives you a free website to use. YouTube allows you to, when you go in here, if I go to, not library, let's see. Now I can't figure out what I'm doing. You can go into your YouTube channel and post videos that are particularly linked to your website. You also have a drive that's kind of like a Dropbox where you can store items. You have translators, finance, word processing that is compatible with things that Microsoft produces, spreadsheets like Excel, slides like we're using today, books. If I click on that, I'm having a little trouble here. If I click on My Library, so if I look up geophysics, it'll pop up with a list of books, right? Now these books come up like this, and what I can do is add this to my library. And what happens then is, again, I'm sorry, it kind of jumps around. But what that'll do is if you click on My Library, you can see natural gases, bromine, geochemistry, oil possibilities around Baxter Basin. So everything that I'm looking up under Google Books gets saved in this list. And you can access this from any computer or tablet. That way you can do your reading wherever you're at. So it not only gives you an office platform with the documents, the spreadsheets, the slides, it gives you a book depository, it gives you an open drive, it gives you a photo album, it gives you an interactive calendar, a YouTube channel. And in addition, it gives you these. I'll go back to our actual presentation. It gives you this entire list of approximately, what is it? 81 different applications that you can use. I got to keep an eye on the time. And that includes like what Matt's going to talk about when what Matthew will talk about when his session comes up. It has a Google Colab, which essentially is a remote cloud-based terminal for coding. So it's what's called a Jupyter notebook. So it uses Julia, Python, and R in conjunction with GitHub. And that's something that Matthew Bauer will touch on. And that's extremely important when you're starting to do more of the interaction with writing your own programs and scripts. There's Data Studio, which allows you to do data reporting. I did touch on the calendar. If you look through this, I mean, the list is extensive. You've got quite a bit of stuff that you can do here just in the Google platform. So as a pitch to Google, I guess, I hate to do it, but they do have a pretty robust setup. The kids that are currently in school right now, at least in Wyoming, that doesn't mean that it's national, but they're all using Google platforms to produce, present, and store all of their homework. And that means that this next generation is being brought up on that platform. So its longevity seems to be a lot more than some of the other platforms. But that's all, unless there's any questions, that's all I really have on Google. It's really short, but no questions? I can't get this thing to work right. Okay, if that's the case.
I was going to say you should keep an eye on the chat. There's some things on the chat.
Okay, all right. Use Google domains for company domain web page. Yeah, not everything is free. That's true. Like any other platform, there are paid things that are in here, but as far as being a comprehensive sort of small scale platform, it really works well.
Yeah, and they have, I mean, the enterprise options they have are pretty expansive. We, until recently, the Department of the Interior was using Google for Government for basically all of our web hosting, email, file transfer, all that sort of stuff. Now we've switched over to O365, and having had a front row seat to how different the two are, you know, there are things that Microsoft does well, but there were definitely things that Google did a lot better. So either they all have their little idiosyncrasies.
Okay, with that, I'll hand it over to Maren, who's going to spend 10 minutes talking to you about what she's going to present today. So go ahead.
Oh, okay. Let me share my screen. Hold on. Can everybody see it?
Looks good.
Okay. So I'm going to talk a little bit about GIMP. And so before I went into oil and gas, I was a paleo person. So images and diagrams, and we were very image heavy. And so I learned to use a lot of these graphics programs. And when I was a student, I had access to all the nice expensive ones, but now I need to find an alternative, and GIMP is a really good, robust alternative to some of the more expensive image programs out there. So why would you need image manipulation in geology? You might need to alter your maps if something happened to them, or add a little bit of annotations to them. You can even create your cross sections if you don't have a cross section software. I create my exhibits using the image program. Sorry, this is my son, Everett. Say hi, Everett. Another thing that I use image programs a lot is for deleting backgrounds and extraneous elements in an image so that I can put it into a presentation or exhibit and make it look a little bit more professional. I also matching colors. If say you're doing a map and you need to copy a color that is in another area of the map, you can do that in these image software. And also I do it a lot with merging images, taking one piece of one image, moving it to a different image to make a more professional looking diagram. So here's GIMP, and it is free. It's open source. You can go to gimp.org to download it. And on the right is just some of the things they say they can do. Mostly it's for like photo retouching and using as a robust paint program, but you can do a lot more with it. And I wanted to give you a couple examples of what I use GIMP for in my professional setting. So here's the GIMP platform. You can, I highlighted some of the things I use. Here's where all your tools are, where your history is, your layer data, how you can edit your fonts and your brushes, things like that. And so one of the things I love to do with these image programs is I like to make my maps look better. I don't know what program you use to make your maps, but sometimes they don't look the way I want them to. And that's just a computer issue. So I use these image programs to make them look better. And you can crop things, you can resize them. Here's an example of where I use the clone tool to retouch this piece of an isopack. So you can see it's all jagged on the edges. I made it look better how I wanted it to look using the clone stamp tool. You can also do the match color tool, which I have on another slide. This is the color matching. Like I said, here, the computer program I used to generate the isopacks didn't fill this in with yellow like it should have. So then I can color match over here and fill this in with the color that I want. And that way it looks the way I want to present to the Oil and Gas Commission or wherever else I'm presenting my exhibits. You can also do all your text annotations. So like say you generated the map, but you want to add some things later, you can always put in text boxes wherever you want, move them around, kind of like PowerPoint, using the text feature, whatever fonts you want. They have a lot of fonts in there, colors. You can alter the text to fit whatever angle you want, or you want it to follow a line, and you can have it follow a line. And this is one of my favorite features, the background deletion. You can use this free select feature and go around your image. This is a piece of the KT boundary, by the way. And then you can delete the background. And so when you plug it into like a presentation or a diagram, this would be a free image, and you can move it wherever you want. And this would be a transparent background, or you can change the background to whatever color you want. I also like to draw on my pictures to illustrate formational boundaries or crossbeds, other geologic features, and that way you can get a professional diagram to submit. Like this, in this case, this is the muddy channel in incising on the Skull Creek Shale, so I just illustrated that. GIMP also connects to other freeware that are very similar to GIMP, including Scribus, Inkscape, and Swatchbooker. I've never used these, but I'm actually interested in using these now that I figured out GIMP connects directly to them. They're all open source, and they're all for creating graphics, doing graphics designs, and which would be very handy for any sort of exhibits or diagrams in a geologic setting. And I believe that is all I have. Yep. So it was very just quick overview of GIMP. I like it a lot. It's a very good program to in lieu of more expensive digital image programs. So anybody has any questions, let me know. Get out of here.
Does GIMP work on Macs as well as PCs?
It says it does. I don't use Macs, but it says that it is good for Macs as well as PCs. So you could always try it and see how it works.
Okay, and does it require kind of a updated operating system? What kind of requirements does it have?
I haven't really checked. I'm using an older Windows on my work computer and it works fine on that. I don't know how far back it would go. I think I'm using Windows 7 even on my computer at work and it works fine.
Okay, thank you. Sounds great.
Well, you're welcome.
Hey, Marion, there was a question in the chat from Laura Johnson on how you use GIMP for making cross sections. I assume it's similar to what you would do in Photoshop or Illustrator.
Yes, and it's not as easy to work with GIMP to make a cross section if you have a more a program that's actually designed for that. It's a lot easier, but you can crop your logs however you want, and then you can adjust their heights to match up to, and then put your formation tops on there. It's like I said, it's not great for making cross sections, but in a pinch, it works. It's just a lot of extra work to get them to line up. And then you can annotate them however you want and put scale bars in however you want, whatever you need to add at that point.
Okay, it looks like there's a few more questions. We've got a few more minutes since we're running ahead of schedule. So Suzanne Caro asked, what are the types of files that can be imported, and what file types can you save your products as?
So far I haven't tried every file type to import, but all the normal image files have imported just fine. I have not tried to import a PDF. I know some of the other image programs you can. I haven't tried on GIMP, but it might be something that it can do. But so far, JPEGs, TIFFs, PNGs, all those import just fine. And what was the other question? Sorry.
Well, some of the stuff's being answered in the chat as we speak, so.
Oh, okay. And oh yeah, I was saving. You can save it as whatever you want. It saves as a GIMP file, and then you can basically export as other things like a JPEG or a TIFF, whatever you need.
Okay. I wonder if you can import GIMP directly into Illustrator or something if you end up accumulating a bunch of GIMP files and then eventually decide to upgrade to Adobe. Do you think, are they going to be cross-compatible, would you guess?
Probably not directly, but it's easy to export any of your GIMP files as a JPEG or a TIFF.
Gotcha. All right. It looks like the chat has calmed down a little bit, so I will grab the screen and get started. All right, so I'm going to talk a little bit about a tool that I've used for data extraction and essentially turning image data into something tabular that I can manipulate, replot, and incorporate into other data sets I have more easily. So this is a product called Web Plot Digitizer. Essentially, it's a way just to extract tabulated data from graphs and other types of images. And quick overview of what I'm gonna talk about is shown here. So I'll talk about where you can access the program, a little bit about how it works, some of the data inputs, and how you can extract images from different sources. I'll show the app interface and a very quick and dirty example, and then show some links for additional information, because there's a lot more, support files that are accessible through the creator's homepage. So this is the sort of the screen that pops up when you first look at the Web Plot Digitizer website. This is a free open source web-based tool. Works with a lot of different types of charts. There's a bunch of different functionality built into this, and I'm only going to scratch the surface of it. But essentially, it's a way to extract data from images, and there's automated options. I'm only going to show one of the manual examples, but there are ways where you can import images directly, and with setting a couple of parameters up, have it more or less automate the data extraction from certain types of plots. And my understanding is I don't know if the developer has put this together yet, but there was talk about an R package that would allow for sort of batch processing of large numbers of images. So that'd be something to check out on the user's website or on the creator's website. Getting into how you access this, I guess the first thing I should say is there are other tools for this type of data extraction. And the better ones I've seen are either not free or don't seem to have the range of functionality this does. Now, I haven't done an extensive survey of the software options that are out there, but for me, especially for just extracting information quickly from a couple of images, I've found this to be a really useful tool. So you can access it at automaris.io/webplot digitizer. And as I mentioned before, there's a wide variety of plots and charts that are compatible. Basically anything with a coordinate system and data points or plotted curves, you can extract data, including maps. In fact, in one of the examples given in the PlotCon presentation that the developer has on his webpage, there's an example of a contour map that someone was able to digitize all of the contour information directly from an image and utilize that in their own work. As I said, there's some automated options. I tend to, again, because I'm using this usually to extract a couple of data points quickly for supplementing other data I already have, I tend to use the manual option, and that's what I'm going to show you. But there is a lot of automation you can take advantage of if you want to. It's cross-platform. There's a web and a desktop option, so you can actually download the app if you're going to be using it in in situations where you may not have access to the web. So that is a possibility. And interestingly, I didn't know this until I started putting this slide deck together, but the tool has actually been referenced in a number of published articles where people are using it and then throwing it in their methods section to explain how they got the data they're using. And one other piece of functionality that's highlighted on the home page that I thought might be of interest to this group is that you can use it to estimate distances and angles from images directly, which, if you want to pull a compass out and a ruler, you can do it yourself, or, you can take a photo of it with your phone, import that into the app, and you can make potentially more precise estimates, particularly for images that are, I guess, web native or digitally native. I assume that the accuracy of the software is going to be comparable to someone who's really competent with geometry tools. So there's two main workflows, and I'm just going to quickly summarize. First thing you do is load an image, and I'll show a couple of options for how to do that and the file types that are preferred. The next option is to calibrate your axes, and essentially, like I said, whatever coordinate system you're looking for, there's probably an option in this app. The examples that are shown here are XY bar charts, polar axes. So if you're looking at, I guess, like a windrows or something along those lines, there's an option for that. You can also do ternary diagrams. So all of you who are interested in mineralogy data and have a bunch of old Clay Mineral Society papers that you don't have tabular data for, and it was never, it may have never been published, you can actually extract that information readily from a ternary diagram. So then comes selecting your extraction method. And if you want to go the automatic route, there's an option to select the part of the chart you want the app to focus on. And that just kind of speeds things up and allows you to, if there are data points that you want to extract and others that you don't, you can just highlight the stuff you want. So you mask that out, select the color of the data points that you want to extract. This is particularly useful for color diagrams, obviously, but even grayscale, it works pretty well. There's a couple of parameters you can tweak if you're trying to extract data for a line, a continuous curve, or something along those lines. You can actually set the resolution of data you want exported. So you can adjust the delta X and delta Y for what it pulls out, along with a few other options that I'm not going to get into. Then you visually inspect the result, see if it looks right to you, and export the data. Manual route, obviously, you're kind of doing the same things, you're just doing it by hand, where you go in, you pick the data points, and export your data. So getting into a couple of capture methods, first off, I'm going to talk a lot about using MS Paint, but you could use GIMP, you could use anything where you can import an image in and save it as either JPEG, PNG, bitmap, or a GIF, or GIF if you're picky. If you're looking at, I mean, a lot of times I'll see data on web pages and articles on like, oilprice.com and things like that, and just want to play with the data. And with that, a couple of simple things. Print screen is your friend. You can just print screen, import your image into Paint or GIMP, crop out what you want, and then import that directly into the app. You can also use the snipping tool, or I think it's now called the snip and sketch tool that's built into Windows. Either of those work fine. As long as you get this into a JPEG format, you're good to go. Photos, I mentioned you can take photographs of data that you want to digitize. This is an example of some Gulf Coast geothermal gradient data sorted by formation age in South, I guess it's in Mobile Bay. And all you've got to do, take the photo, get it onto your computer, crop it out in MS Paint, and that's optional. Actually, I'll show you that you can just use the images directly if you want. And but as long as it's in a JPEG or bitmap format, you can then start working with it. And then last, one of the more obvious is PDFs using the snapshot feature that's under the Edit tab. Again, paste that into some software where you can convert it into a JPEG, and then you're ready to go. Now, you may be able to paste stuff directly into the desktop version of WebPlot Digitizer, but because I use a government computer, I'm not supposed to use software that's not approved, so I do all my stuff through the browser, and it works very well. So you may be able to skip this MS Paint step in some of these cases. But as you can see, if you've got an old paper from like a conference proceedings and you really want this mineralogy log, it's pretty straightforward to get it once you have this tool. So the example I'm going to show very quickly is going back to that Mobile Bay geothermal gradient data. And this shows the interface of basically the first screen you see when you go to use the tool online. And you'll import your image under File here. So it's pretty straightforward, kind of a standard PC interface. You import your image. There's a calibration option, or calibration is pretty much required. You have to set your axes and define your coordinate system. And it has some neat kind of built-in features where, like, for example, you can see here that my hand was not super steady when I took this picture, and I was maybe holding the camera at a little bit of an angle. Well, the program has algorithms built into it that can adjust for that. You can turn those off, but if it needs to auto rotate or adjust for the angle of the image, it's going to take care of that automatically in the background, and you don't have to worry about it. Then you pick your extraction method. As I said, if you're going to do manual, one really neat thing is the area that you're focused on. There's a zoomed in window in the upper right-hand corner, so you can really nail the dead center of that data point. And that's important because whatever you extract, you're going to be introducing some additional error. So getting as close to the actual center point of the data you want to digitize is important. So it's good to take your time and kind of look at this carefully. And then you export your data. You can do it as a CSV. You can copy and paste into Excel directly from the app, and I'll kind of show you what that output looks like. So the calibration step to start, once you've got your image imported, you're going to hit add calibration. This little window is going to pop up asking what type of chart do you have? And in this case, it's XY data. So you're going to pick points on the X and Y axis to calibrate. And once you do that, you can see here I've got them on my image. You put in the values, hit OK, and you're calibrated. You've got a coordinate system, and now you can go in and start picking your data points. So if you do the manual option, like I always do, because I tend to be looking at, between 5 and 20 data points, so it's not too onerous. You pick your spots and then hit export, and you've got a couple of different options for how you can use the data. You can either just put it on the clipboard and then paste it into Excel, download a CSV, or if you have a Plotly account, you can manipulate it directly in Plotly. So it's kind of a neat feature if you're using, if you're a very online power user type, you can do everything just through your browser if you want. This is just another XY example, and this one was a little frustrating to me because this is a USGS report from the mid-ish 90s, and it's got some vitronite reflectance data for an Exxon well in Mobile Bay. And I thought for sure this vitronite reflectance data would be in our geochemistry database. Somehow it wasn't, but that's not uncommon. Not all data gets captured, even in an organization like the USGS. But one of our basin modelers really wanted to use this, and she didn't want to have to take a ruler and figure out, especially with this log axis, what the values were on all of these data points. So she asked me to take a look at it. I just, in 5 minutes, imported it into WebPlot Digitizer, pulled the data points out. You can set a log axes if you want. That's one of the options that's built in. And I was able to digitize this and integrate it with IHS tops in maybe 10 minutes. So it was very nice. I sent it on to our basin modeler. She's using it now for some work we're doing in I believe this is for the Smackover project. But anyway, it's the kind of thing you can do in no time, and comes in very handy. So, and this wouldn't just be if you're interested in using freeware. I find this to be super useful, no matter what software I have access to, just because it's so easy and quick. So as promised, here are some links to additional information. There's again the homepage, very nice 20-something minute presentation from the 2017 PlotCon meeting where the developer shows off some of the capabilities. There's a detailed manual with step-by-step instructions for different types of charts, very detailed tutorials. This link will actually take you to a table of contents where you can go to particular parts of this YouTube video based on what you're interested in. You don't have to sit through the whole thing because it's kind of long. But yeah, that's what I've got for you. And if there aren't any questions, I will hand off to John. Oh, we got some stuff in the chat. Let's see. Precision. Yeah, you're right. Yeah, precision. That's right, Mike. So yeah, Matt's already, looks like most of these may have already been addressed. So okay. Well, we'll have some time at the end if there's additional questions or that sort of thing. So in the interest of time, oh, we're pretty much right on time now. So John, take it away. We didn't lose John, did we?
No, I'm starting my video.
Okay, sorry.
I had it turned off. There we go. Okay, let me share my screen with you. Okay, can everybody hear me and see me? See my screen?
I can on
Yep.
my end.
Okay. Well, that's good. I'm here to talk about a program called QGIS, or if you're in the cool kids club, QGIS. And I have a set of slides here that is a preface to a live demonstration that I'm going to use. I'm taking my, I'm risking showing a live demonstration that I won't have a computer crash or a data snafu. So these four slides are will go flawlessly, however. QGIS is an open source, meaning no cost to the user, geographic information system useful to geoscientists for data organization and analysis, mapping and interfacing with other applications. And if you have ever used a mapping program of any sort, but particularly the ESRI, ARC, ArcMap, ArcInfo, you're already probably pretty familiar with what a GIS program is. If you've used other commercial mapping software, and I'll throw out Surfer, Petra, Petrel, Geographics, and I'm probably missing a few, but I throw those out. They operate in a kind of a GIS-like environment where you import data, you turn layers on and off, and you can do an analysis of the data that you've imported. Now, what can QGIS do for geoscientists? Well, you can organize your data into projects. Everything is put in a relational database. The underlying data appears as either tables or images. You can analyze data spatially, so you can measure and compute and analyze. You can grid and contour point data. And this is actually one of the things that got me interested in it for reasons I'll explain in a minute. You, of course, can generate maps because everything that you're looking at usually is a map in QGIS. You can georeference raster images. And to me, this was a very important tool to have because there's a whole cottage industry, including APG, who has figured out that all of the old legacy maps and data that's in and maps that are in publications and so forth, if you capture that as an image, you can also put that in a GIS program as long as you have georeferenced it properly. You have access to online open data servers. For example, Google, you can pull in the Google Earth layers into your project. USGS, you can't yet pull in all of their geologic maps like you can in their own online server, but perhaps that'll be down the road. You can export data and interpretation for use in other programs and platforms. For instance, you can export shape files for use in Google Earth or CAML files, KML files for use in Google Earth, and you can look at them on your phone. Now, GIS does have a phone version, but it's kind of a downscaled version to the desktop one. You can operate in 3D space, which is not voxel space. It's not actually true three-dimensional pixels, but it'll give you perspective pictures of landforms, particularly using digital elevation models. And you've seen, I'm sure, a lot of these pictures before of say, a map surface draped over a digital elevation model and looked at in perspective. You can also generate cross sections and log displays. And I do have an asterisk next to this because the company that kind of pioneered this use for QGIS is called, well, the company's name is Oslandia. They're a French company. And their product was, or their widget was called Albion. And it worked really well in version 2, but we're up to version 3 now. And as you'll find out in using open source, things that worked in older versions don't necessarily work in newer ones. So you do have to kind of work around that limitation. So why would you want to use QGIS if you can use some other mapping program? Well, it's powerful and it's free. And it has a large worldwide community of users and developers. However, it is mostly used and supported by European countries. I don't know what kind of a user group there is in the US, but in fact, I wouldn't even say the United States is lagging behind in terms of use. I would say all of the Western Hemisphere needs to come up to speed on what is basically a European product. And then finally, it's a GIS program that incorporates kind of the best of widgets from other open source GIS programs. And these include GRASS, the old Department of Defense program, GDAL and Saga. And it has a user-friendly interface. So if you don't know Python programming, which would be very handy to know, you're not going to be at a loss because it is kind of a point-and-click environment. Now, who am I? Well, I'm independent geologist and geochemist, and I'm independent by virtue of having been liberated from my employer in late 2019. And I was actually pretty happy about it. But one of the first things that I confronted is, well, I don't think I want to play golf and watch TV all the time. I really want to just keep doing what I'm doing. But now I have the freedom to work on what I want to work on. But in order to do that, I need data and I need software. And so I knew about GIS because I had used Esri products before. And so that's kind of, and after doing some research and installing, I installed Saga. I didn't install Grass. I didn't have to because it's actually a module within QGIS. And then I installed QGIS. And I finally settled on QGIS, which I'm really glad that I have. There's a learning curve like there is in any other kind of software, but it's worth the effort. My professional interests revolve around four things, and they're narrow yet broad. Petroleum systems analysis, source rock geochemistry. I was a geochemist for the last 5 years of my career. Field geology and paleontology. So you can see the kind of projects that I'm interested in are areas and basins and projects that incorporate elements of both field geology, surface geology, and subsurface geology. And I come at it from the space, on the ground, and in the subsurface. So on that note, let me open up and hope for the best here. QGIS. I need to get something out of the way there. So this is, for those of you who don't recognize this, this is the state of Oklahoma in South Central United States. And what I've done is that I have put groups of related files over here on the left. And so with the little button, you can open up that and get a whole variety of files that you can overlay. So we're going to kind of work our way through some of the kinds of data that I have in here and some of the kinds of analyses that I've done. And when we get to the end, I'm sure you'll have some questions about about any of this. One of the I always put as a matter of policy, I always put my raster base maps on the bottom, and it's because they are opaque, but you can make them as transparent as you want. But I do as a first pass, I put them on the base. So as I mentioned, Google is available on here, and when you load QGIS, you get by default one called Google Imagery. There is, however, if you do some Googling around for other sources of online data, there is one called Google Imagery, and that's more like what you see in Google Earth. So it's a little higher resolution. You can zoom in really beyond the resolution, and it's handy to have as well. They've got a product called Google Roads. This is something that you download. I mentioned digital elevation files. And well, how do you get these fancy draped geology over topography? Well, you start with a DEM file, and DEM, digital elevation model. And when it comes in, though, for example, when it comes in, it doesn't actually come in as a hillshade. It comes in as single band gray, and you can see what that looks like. It's kind of not as jazzy, not as interesting as the hillshade view. So this is kind of nice because in the old days you would have to go to a government site and one by one download these things. But as it turns out, there is a widget baked into this, and let me show you. This whole program operates on plugins, and so here is where you get plugins, and I have so many plugins that I've installed, and honestly, I probably don't know what half of them do. They just sounded like they would be good for something eventually, but there are a few that I use quite frequently. And as I mentioned, plugins are really the extended value of QGIS. They allow you to do things that are non-generic in nature, if that kind of makes sense. So, oh, let's see, one other layer on here. Well, I'll show you two other layers, actually. This is actually one of my favorites. This is a USGS layer, and this is gravity. Now, gravity is gravity measurements reflect two things. They reflect the composition of the basement, and in some cases, the depth to the basement. And so here we are. This is kind of my focus area up here. And this is the Arkoma Basin down here, which looks like a proper basin. But interestingly enough, this is the Anadarko Basin over here. And except for this spot, which does happen to be the deepest part of it, a lot of the Anadarko doesn't have this sunken appearance that the Arkoma does. This is a feature that I'm interested in up here. And it is rather than being a low, it's a high. And so these are all highs. This is the Wichita Mountain Range, and here this is the Arbuckle Uplift. And this is it isn't so much of a high. It is high, but it's not a mountain range. Let's put it that way. And it's very interesting geologically for a couple of reasons that I'll show you in a minute. Now, other base map layers in here, and this is one that I absolutely love, is US topo maps. And at this scale, all you get is shaded relief. But if you zoom in, progressive zoom ins on this get increasingly finer scale USGS maps. Now, what I've done on here is I've turned down the transparency on it. So let me turn it up just a little bit so we can see it better. Yeah, there we go. So here you're probably looking at a 1 to 250 scale map, 250,000 scale map. There may be the same thing, but when you zoom all the way down, that's probably 1 to 62.5, and then you get to this, and you're at 7.5 minutes, 1 to 24,000, 7.5 minute quadrangles. And you can take this and you can drape it over your DEM layers, and this will stand out in 3 dimensions. It's all pretty nice. So anyway, a really impressive set of raster base maps. The default ones that are loaded are not necessarily well, they're not everything. In fact, they're just a fraction of everything, but you do have to do some rooting around to find out where to get more. Now, let me kind of work my way up here. One thing that I did, let me do something here. Sometimes things disappear and you either have to refresh or go up here and hit this little button. So that's what I just did. And one of the reasons that I'm talking to you today is because one of the needs that I had as a geologist was to be able to take point data and generate a grid and then contour the grid. And this is something I used geographics, but you could use Petra or Petrel, or even ESRI has a plugin for this. But I didn't know if any freeware had anything that was really comparable to what I was used to using. So I'm actually on the wrong thing, but I'll show you this first. Here, for example, is a Woodford structure map. And this was done with points. I don't have the points laid on here, but this is the one that got me famous on LinkedIn. I made this map, and this is actually prettier than the one that I put on LinkedIn. And this is done. It's a two-step process. Number one, you have to create a grid, and number two, you have to contour the grid. And in this case, what I've done is I've clipped, this is called clipping. I've clipped both the grid and the contour set to the outline of the data. And where you do this is in the all-important toolbox. And the toolbox has, I haven't counted them, but it has a lot of stuff in it. And these are the Python language widgets that do the kind of non-standard stuff. Although there are a certain number of these that come in when they're loaded in. But for instance, gridding and contouring Now, contouring is something that somebody who works with DEM data, for example, that's the easiest data in the world to grid because it's all uniform size, it's dense, and it makes beautiful contour maps. What I didn't know if you could do or not, if you could take something really ugly data that was dispersed, that was clustered, that was sparse, and actually get a grid out of it that would look like anything at all. So what you do to find things, there's two ways to find things in this program. Number one is this search. And if you type in grid in here, you will get more grid stuff than you imagine would be in here. And fortunately, and I don't know if it was rigged this way or not, but inverse distance weighting is the one that works out of the box. If you get down here and you start playing with grass and saga, they may work, or they may work on certain kinds of data, but I haven't had as much luck in generating things like this that look the way I think they're supposed to look. And my reference is those other programs and how they make gridding and contouring look. So that's how you do gridding. And contour is the same thing. You just type in contour and you'll get a bunch of contours. The one I use is called Geodel, which is another GIS program. And as I mentioned, QGIS has harvested these plugins, Grass, Geodel, Saga. Those are not their plugins, but they adapted them for use in here, writing them as Python widgets for this program. So so anyway, that's kind of the map that made me famous. There's more stuff in here, and just for comparison, there's a map of the same data, well, almost the same data that Brian Cardot's data, and in that case, the Woodford tops are a little more normalized. Mine was using just a raw data download provided by operators to the state, whereas I assume Brian cleaned this up, that he verified it against logs. I don't know that he verified the ground level or not. And that is sometimes an issue with wells, is that there's a discrepancy between the reported top of the measured depth versus the real altitude in a given place. So this is powerful stuff. This is what I wanted. This is half of what I wanted. And so now these surfaces are not faulted. They're smooth grids. And if you want to do faulting, you're going to have to go in and do a bunch of hand editing is the only way that I can figure out how to do it. Here's one for the whole state, and this is vitrinite reflectance. And you may have seen, I posted this one online, and you may have seen it. And this is really kind of an ideal data set. You can see it's sort of evenly spaced. And it doesn't leave a whole lot to the gridding and contouring program of making up wild stuff that doesn't exist because you don't have any data. And I compared this in my little online post. I compared this to a map that I did in Geographics a number of years ago, and they look virtually identical. So so that is a very powerful tool. Now, I kind of got ahead of myself here. The other thing that I found to be very useful in here is georeferencing rasters. And let me see what I've got in here for examples. Yeah, okay. This is one that I got a lot of use out of. And this is out of an old Hayden is out of an old USGS publication, 1960s. And it was about, the theme was phosphatic sediments in Northeast Oklahoma. And this is one of the enclosures. It had been scanned. And because I do some work, certainly my geochemical analysis and fossil collecting and so forth is done at the surface. And so I used this map and I georeferenced it. And the way that you georeference in here, again, well, not again, let me see if I can get to it here because I've got the toolbar kind of in the way. Under raster, there is a thing called georeferencer. And it inconveniently puts itself right in the middle of your program. In fact, it wants to dock itself in the worst way. Now, there may be a way to prevent that. But what you would do in this program is that you would load a raster file. And let's see if I've got anything in here. I don't know. Let's see what these are. Yeah, I don't have, yeah, we use this one. Okay, so if I wanted to put this map in QGIS, what I would do is that I would go in here and I would start picking control points. And I would pick a control point here, then it would give me the option of coming back out here and picking the same control point. In fact, you can see there's one of those control points right there. And this one actually is already picked. And when you pick enough, and it's kind of, there are some rules as to how many you pick and where you pick them and so forth. But then you've got this map in there. And with that map, you can do a couple of things, actually. Here's all the the data points that I picked off of there, and I picked a couple of themes. I picked not only the outcrop localities where phosphate nodules had been collected, but I also picked up the trace of the Excello, which the Excello is a black phosphatic shale. And I kind of wanted to know where that went through, where he mapped it through, because there was a structural problem up here that I was trying to figure out. The Excello was not where I expected it to be, but lo and behold, Hayden, who did this work in the 60s, had it in the right place. So that gave me, being able to put this in a map, gave me the confidence that I was not crazy, and that this Excello shale that I found where it shouldn't be by regional dip actually exists. And it's, as it turns out, there's a big fault. It's a 20-foot fault, but it cuts across this area, and this preserved some section in the down drop block that shouldn't have been there. Now, some other things that I have in here, let's see what some good ones to show you would be. Geologic references. Oh, I know what are a lot of fun. Faults and folds. Okay, we're all interested in earthquakes. Let's see if I can get rid of, yeah, sometimes these, if I do a refresh here, we may be stuck with those reference points. Sometimes they stick, and then you can't get, the only way you can get rid of them is to go out of the program and come back in. So if you can just tolerate them being there, that'd be great. Faults and folds. The state of Oklahoma is full of faults and folds. And for example, there are basement faults, which have been coded as basement faults. And these are of great interest to me. These came from the Oklahoma Geological Survey. They have data online that you can download. And this particular set of faults, they're basement faults. And I'm interested in those because they're oftentimes conduits for heat. So if I'm looking for a thermal anomaly, such as exists up here in Osage County, I see kind of an abundance of basement faults that would explain why I have a thermal anomaly where I do. There are these faults, the fault layers were at least the most recent batch, and these have everything in them from the literature, but the most recent batch of faults we got were from operators, and it was in response to the earthquake, the induced seismicity problem that we had in Oklahoma primarily from water injection into the deep Arbuckle, but also from fracking as well. You can shake a basement fault loose if you frack too hard as well, but usually those are of lesser magnitude. So those again come from the USGS, and you can do a lot with free data. And so, for instance, here's a clipped. Let me go up and turn these off because we don't need that. So these are Pennsylvanian outcrops, and generally they get younger as you go to the west. This is the mountain, the Ouachita Mountain belt down here, and the way that I made this file is that I took the Oklahoma bedrock geology, which is this map, and I filtered it. And the way that you filter is that you do a right mouse click and see if it's going to let me do it. It's kind of a big map. Yeah. And hit filter. And there is one of these filter tools in the Esri products. In fact, I think most mapping programs have them. And so if you have, for instance, unit age, and you wanted to do a sample, if you wanted to query for all, let's say, early Cambrian rock in Oklahoma, you would double click unit age, you would hit equal, and then you would hit early Cambrian twice, and you hit OK. And what that does, it applies a filter. And you can see there's not a lot of early Cambrian rock in Oklahoma at all. So the way you get rid of this is you go back and you clear, and then everything's back to normal. So query is your friend, and I use it all the time. How are we doing on time here?
It's just about time for Matt to start up.
All right, I'll cut to the chase. Okay, one other feature in here, and there are so many of them, is about pictures. And you can do things like this. I'll show you. You can add pictures. And I don't honestly know why you would want to do this on a map. But the thing that you would want to do is link map features to, you get my pointer here, you get that tool. You can link map features to a plugin that produces an image. And you can have as many images as you want. But the nice thing is there's also a link in here. So if for some reason you needed to do some editing on this picture, you click that and, well, we just saw a GIMP, and here it is in GIMP. And you can do your image editing in this. Now, the bigger implication of this is that any data, and it doesn't have to be point data, you could do a township outline if you wanted to, but anything that you can click on and have a path to a file type, and then the file type is set up in Windows by a handler, by what we call handling. For instance, in your in Windows Explorer, if you click on a JPEG, it will open in some app that is set up as a handler for JPEG files. And that might be GIMP, it might be Photoshop, it might be Paint, it might be some other program. And any kind of file, any kind of file type that is handled by Windows can be put in here. So for example, if you were using let's say a petrophysical analysis program, and this was a well, and you clicked on it and you got a hyperlink. When you clicked on that file type, if it could trigger that petrophysical program to open and load that file, just like image files do, then you've got a kind of an integrated system. And that is the potential here. Now, I say this, but not all file types can be addressed with handlers. For instance, a SegWi file, a geophysical data file. If you click on a geophysical data file, even if you got OpenDetect, which is an open source geophysical data interpretation package, it's not going to open the SegWi file. You would have to write a Python script and put it in your processing toolbox, so that when you clicked on the SegWi link, it would actually go in and go through all the steps in OpenDetect or whatever your seismic program is in order to just open that file within that program. So you could potentially, the sky's the limit. You could have it linked to any application that you want, any file type to any application, if you can go through writing the scripts. Images are easy. You can put entire logs in here if you want. They're going to open in GIMP or whatever your handling program is. So there's lots more. This was a teaser, and I'll take some questions now.
Actually, John, if it's okay, if you have questions for him, that was great. We'll move directly into Matthew's portion, and then we'll have time for questions a little bit afterwards. But this is an example of something that might transition well into a standalone demonstration where you'd have, maybe 2 hours or whatever I guess the public would request as far as a presentation, something that you could dig into deeper. I use this program, and half that stuff I didn't even know.
Yeah, that's a
So
good walkthrough.
that's great. And I like how it kind of interacts with GIMP, and how, I wrote it in the chat box, but it's a perfect way to georeference stuff and then bring it into any program once you export it. But I'll let Matthew take over. But John, that's amazing. And it was your image, your map of Oklahoma that caught Justin's eye when we were talking about this, and said, hey, get a hold of this guy. He knows what he's doing. So that's exactly what we saw, was that I think it was the Woodford. And thanks again.
Well, you know what they say, in the land of the blind, the one-eyed man is king.
Well, all right, that's a good segue in, because a lot of those plugins are running on Python. Hey, my name is Matthew Bauer. You see a few people I recognize on the attendees list. Won't get into what all I do, but I'm a geologist, Python evangelist, perpetually curious. If you need to get a hold of me, I believe these slides are all going to be made available. I have a ton of links in these, but there's GitHub, Twitter, and LinkedIn. Feel free to reach out. This kind of an intro image, we were talking about public data and things we can use. This is actually a little bit of a rabbit hole lunch that I went down one day, and it uses a package called RidgeMap in Python script in order to make some pretty cool images wherever you want to go, and pulls from a USGS API in order to pull the data from it. So why, as a geologist, would you want to learn Python? Python and some of the packages you can import will allow you to open a lot of the file types and manipulate those that we use, whether it's well logs or seismic or working with shape files. It allows you to access a ton of public data APIs or private ones, so you could integrate with some of your data services. It also allows you to scrape data. Scraping is automating interactions with websites so that you can get stuff that may be across 100 pages into a machine readable format. It allows you to clean data efficiently. Gone are the days of going through an Excel file from a lab and removing minimum detection limits or asterisks, so you can actually get into a usable format. It allows you to interact and work with SQL databases. If there's a workflow that you do every single day, doesn't require a lot of abstract thought, you can automate it. It may take you longer to automate it the first time than actually just doing it, but then you free up all that time for you to do other things that you want to. Because honestly, we want to be doing the interpretation rather than spending the time cleaning up all the data. And if you can clean up that data in a more efficient manner, it makes things a lot easier. Let's say you got almost a little too much data, and either the number of dimensions that you're looking at or the flow of the data is too large. That's where tools like machine learning, it can really help get a clearer picture, or you can do regression to predict something. And then there's geostatistics too. Managing mineral rights is where I've been spending the last couple of years, but it's really useful for that because you can automate, what wells are you getting paid on? You can write shape files directly from the PLSS description. You can compare and then automate so that your interest on the well, back calculating volumes and then comparing those back to the reported volumes. In an automated fashion, you can go in and making sure that, depending on your lease, that the appropriate amount of deducts are being taken. You can, if you'll say you're evaluating, investing in something, You can create type curves for something and see if it actually makes sense to go in. And then why we're talking about it today is because it's open source. So where do you get started learning Python? If you've never programmed before, I do recommend that you take a general course. I like Dr. Chuck's because it's free, hands-on, and it's a good quality course. MIT actually has a little bit of their older Python, intro to Python lectures and their current resources for those classes available as well. I've contributed to Hacker Village, which is an applied series of course and lectures that have those out on YouTube, as well as the source from behind it. Let's say you want a little more hands-on help. I teach a class with RMAG, and this, I don't feel it's a shameless plug, because if you want to go through it on your own, feel free. I put all of the course modules out there on GitHub, and you can walk through those. But if you need a little bit more help, whether it's through lecture or answering questions and that kind of stuff, we do have the classes. I haven't personally used them, but if you're down in the Houston area, Datum, I know some of the folks that run that. They're good folks. I'd recommend that. Let's say you want to go a little bit deeper. Mines is now offering an online graduate certificate in data science and earth resources. Zane, Joe, Thomas Martin, and myself have been working on that project and getting it up off the ground. And I'll actually be teaching this semester Geology 558. It's an applied machine learning course down there. But moving on, I'm from Missouri originally. I'm the show me kind of guy. What can you actually do? So I'll walk through a few examples of these. Afterwards, if you guys want to go through, you can open up these and walk through and look at the code themselves, and feel free, copy and paste it, adapt it for what you want to do. But we'll walk through a few examples of things that you can do. So this maturity map, this 3D one over here, this is the North Dakota section of the Williston Basin, but this went through and merged 3 million rows of analysis to sample locations and then filtered it down to Tmax data. It was pretty darn easy and very quick. But if you were to think about doing that in Excel, you'd have to set up your VLOOKUP, and then you'd have to sort your data tables in order to merge them across. You know, that's a pretty involved process. But with Python, it's actually pretty easy. There's a pretty neat one here too, doing some clay typing. So it opens up data from an LAS file from spectral gamma really easily. So in one line, we calculate the shale. Then we take that and plot that on top of an existing image. So we can look at the interactions between potassium and thorium and the amount of shale that we're having in that area. Here's another one, article I wrote up for Outcrop. You can look at the code in the article there. If you want the working versions of the code, you can grab it from here, as well as if you just want the data from the BHT or the bottom hole temperatures, you can grab it. Whether you're mapping out maturity or you're looking for geothermal prospects, the traditional way of doing this is going and opening up a log, pulling the information out of the top from the header, and then going on. But with Python, it allows you to automate that interaction with those files. Go through and in one evening, you can parse out 64,000 logs, pull all that data in, get it cleaned up. And when we plotted it, took a look at it, you know, there's these kind of suspect data points in here. Is mud still being circulated? Is that pencil whipped? You know, default values, something. It didn't look right. So I just took a look at that, went ahead and removed those, and you can see that here. But then we can take this data, add X and Y to it, and make the geometry column to make a shapefile, and then bring it over and map it out. And you can find areas of interest where you want to spend a little bit more time and correct those bottom hole temperatures. Talking a little bit about freeware, but also free data. You know, there's a lot of stuff that's out there available through oil and gas commissions, but it's not that easy in order to pull it in. But you can take those scripts and you can roll them into packages and share them. This is one of them that I shared. This is COGCC Pi. It allows you to go in, and this is where you import your package, list a list of APIs, and then one line, and then we can pull it out in data frame for both production data as well as formation tops. And I gotta update it afterwards, but I usually throw a zip file of all the formation tops out there for Colorado out on the GitHub too. Let's take another example. If you're working freelance, you probably don't have several geologists available to work on a project and make picks, right? And then you compare them and see what other people's opinions are. The nice thing about machine learning is that it's an unbiased, it does it in an unbiased way. So you can use this as a tool. And, there's lumpers and splitters, but you can actually use methods like the silhouette method in order to say, okay, by the data, how many faces should we be looking at? And then you could generate this on a very quick basis and then use this to assist in your picks. One of the other things in this example here is we actually calculate the Euclidean distance. So this is saying for each point in that well log, how well does it fall into the family it's associated with, or the facies it's associated with? And that goes from each point to the centroid, or the center of the family, and measures that distance in between, and then plots that. So we can see beds like this right here. So what's going on there? If I had to take a guess, there's probably some differences in fluid saturations there. This is another example. This is from Courtney Bones' thesis. I helped her out with some code, and we were looking at a large amount of XRF data. And compared to other methods of dimensionality reduction, we run into preserve like what? Oh, where he had enrichment or depletion. So she had her core facies, and then we went through and figured out the appropriate number of clusters. And then went through and then assigned those, and we looked at each of these and say, okay, what elements are enriched and which ones are depleted? And that helped really tell that story of what was going on in the system.
I think you're muted.
Am I muted?
Oh, there we go. Now I hear you.
Oh, okay. This is another.
Hello.
This is another example of something I did with Michael Hardy. So we were actually looking at stress directions in the DJ basin. Yeah, I'm not muted. And we were looking at well borehole breakout from LAS logs.
Do you have like a, say, the data outline of the ZAMP survey?
What was that, Stephen? Mute that. Okay, so 6-arm caliper logs are kind of interesting because what ends up happening is because the arms are actually independently hinged, the tool will move around in the hole. So compared to a 4-arm caliper log where they're hinged together in either axis, and the tool rotates and catches in the breakout and then rides that up, the 6-arm caliper logs don't necessarily have that behavior. But what we were able to do with a Python script is recenter the tool in the center of the hole and then fit those pad points to an ellipse and then calculate its eccentricity so we can measure areas where we had breakout and then measure stress with that. Let's say you got a project that you're not quite sure how different variables going into that affect the outcome of the project that you're looking at investing in. You can run a Monte Carlo model. This one was ran with NumPy and NumPy Financial. We put our inputs in the distribution type and the ranges that we expected to see them, ran the same things that would be for going in over a number of iterations. And then we were able to see, okay, what are the ranges of outcomes that we expect to see? How does each individual input variable affect how what we see as the outcome? And then we were able to do some nice plots of looking at, okay, when's our payback periods and that kind of stuff. So enough examples on that. These are some of my other geocomputing favorites, and all these have links to them on the backside, so you guys can take a look at them later. If I had to pick one blog, it would be Agile. They do some pretty cool projects of like 10 lines of Python. They also do a lot for the community, talking about software underground. It's a Slack group, a bunch of geologists, engineers, geophysicists that all go in and they code and share their favorite articles or packages or things that's happening in community, job postings. Kurt and Mindy, if you're looking for a lecture series, during COVID, it's online, but here, if you're in the Denver area, Denver Data Drivers, that's a really kind of fun one. Favorite kind of machine learning project that's going on right now, up at Madison, Geo Deep Dive. It's really pretty cool. They're going and they're taking with OCR and natural language processing, and they're reading all of these old articles and pulling all the dark data that's in the articles, whether that's fossil occurrences, mineral occurrences, formation names, and they're linking all those things together, and then they feed out whether it's through my favorite API, which is MacroStrat. You can get a lot of information out of that. And if you haven't heard of it, I highly recommend checking out Rock. It's an app that goes on your cell phone, works as an interface for all that. And I mentioned Geostatistics before. Dr. Perch down at UT Austin, he has all of his lectures out on YouTube, as well as most of his materials out on his GitHub. But there's a link for that too. So really quick, I think we have about 15 minutes left in my section here. Let me get to where did hold on a second, where's the chat? Where's the chat? So if everybody take a moment and let's see here, get this chat up. And head over to there. But what that is if you could just take a bit and vote on which one you'd like me to walk through. It's 15 minutes, which isn't quite enough to go through and explain everything, but I can show you an example of basic syntax, some logic functions. If you want to see that clay typing example, we can do that. I can walk through about how you build a scraper, or I can demo an unsupervised machine learning model for that log facies that we saw up above, or we can do a mixed mineral model too. So if you take a moment and vote for that, and we'll go with the winner here in just a couple minutes. Give people a little bit of time to hop in. Okay, I think we have a pretty clear winner. Okay, it looks like the unsupervised machine learning log facies model is the winner. So if you guys are following along, you can actually just open this up in Colab, and you don't have to install Python in order to run these with Colab. It's a kind of a nice thing. So, but if you want, you can actually Google my GitHub and then hit open in Colab if you want to follow along with this. Colab, what it actually is doing is it's running an instance of Python out on Google servers. It has a lot of really common packages like pandas, which is kind of like the database or Excel of Python, previously installed, but ones like Lassio, which open LAS files, we have to open up and install for that instance. The rest of these, this is sklearn or scikit-learn. That's a machine learning package. We have some stuff for changing some options here and how we do it. But what I'm doing is we're reading in an LAS file that I have out here online. There's some bad values from before, so we're correcting those and dropping them, making nulls. We'll preview some of our data and make sure it comes out. So for the demonstration purposes, we're only going to run with 1,000 feet of this. So we'll filter it down to that and only surmount curves. And when you're building a machine learning model, there's a couple things you need to do ahead of time. You need to actually usually scale the data that's going in. And this is because there's a difference in between having something that is logarithmic in scale compared to something that is linear. And what this will allow us to do is scale all that data so it's from 0 to 1. So we'll do that. And you can see from our curves from before where they're units that as geologists we're used to looking at, now they're all from 0 to 1. The next thing we want to do is we want to run something that's called a silhouette score. And what this does is it runs the model several times. It goes in and takes a look and it says, okay, which one of these, we want the peak here, is the most appropriate based off the data for the divisions of the data. Another method, the WSS or elbow method. With this one, you want to look at where that curve breaks over. So right around here, around 4 or 5 is where we want to run with that number of clusters. So this is where we build our model, and this is where we've trained it for the unsupervised, and all we're providing is the number of clusters, and then X is our data that we're feeding in. And boom, we just trained an unsupervised machine learning model. This is going in here and calculating the Euclidean distance. So for that one plot that I showed you in the slides, that was for 3 dimensions. This is for as many curves as we're feeding in. So, but you notice here, before we go back and plot it, that we're still in that scaled space. So what we're going to do is we're going to take it from our original data frame to the data that we trained on, and we're going to transfer that data back over. So now we're back into units that look more familiar to us. This is some functions in here. You're welcome to look through them if you like, but all this is doing is it's making a nice plot that we can go through. And a lot of this is actually based off of Brendan Hall's work. He's at a lot of the conferences, so if you ever see him, go by and say hi. But then we went through there and here pretty quick. We just went in and, you know, built a model, trained it, calculated our Euclidean distance, and then plotted it up. But you can see some things where we have a high PE. Those definitely look like limestones, maybe some source rocks in here, and some dirty and clean shit, or dirty and clean sands. But I think, yeah, but that's about it on time. I think we're actually now going to go over to any questions. And Mike, I think I'll turn it back over to you.
All right, well, thank you so much. So yeah, we have an open time now for about a half an hour. I guess, you know, if you have any questions, you can throw them in the chat window. I don't know if you actually have control over your muting options. But we could also do it so you raise your hand and then I can unmute you if you want. I mean, that's kind of, that'll prevent us from talking over each other, I guess, too.
Hey, Mike, when is, are we going to send around a link to these slides too?
Yeah, right after this is done, I'm going to convert this over to, well, it's going to convert the recording and then we'll place this online. I mean, I'll send a copy to you and all the presenters. You guys can do whatever you want with the information and just send it out. Send it to everybody and anybody.
It looks like one of the questions that's come up is companies that make these programs, how do they pay for the freeware? And I think this is all, because it's open source, it's basically just volunteers putting these things together and making them available. At least I know that's what the plot digitizer is kind of how that works.
Yeah, volunteer hours, grants, that kind of stuff.
That's what's cool about this too, is if you have a specific, you know, there's a lot of questions about doing cross sections and stuff like that. If there's something that you're interested in seeing completed, being completed, there's a lot of these user groups or forums that you could put in that request and you'd be surprised. I mean, some people will just pick this up, see it as a challenge, figure something out, and you might have your results. I don't know. It kind of just depends on what it is, but it's like solving puzzles. So. And, you know, we also were talking about doing that, a second follow-up calling for free data for freelancers. But I guess just based off of our interactions that we're seeing in the chat window and kind of what we're talking about while people were giving their presentations, it might be kind of cool just to start a list somewhere online, and I'm not sure how to go about that. And in lieu of actually having a discussion about it, just providing those materials. If you guys look in your links in the chat window, there's quite a few that were brought up. So those are some sources if you know how hook up your map servers and your programs, that's where you're going to want to look. Specifically, I was kind of, if nobody has any questions, does anybody? I don't want to talk over anybody. Your gravity map, John, I'd like to get a gravity map of some states in the Rockies without being too specific. Where would I do that? I've got a GravMag survey that I picked up, but I would like to see it. I'd like to see what your sources show versus what I've got. Does that make sense?
Yeah, the USGS is as far as I know, they're the biggest source of free gravity data. And all you have to do is search for USGS gravity data and you'll get there. I forget, it's been a while since I've downloaded anything, but I don't know if they do it by state or by region, but I'm going to say they probably have it over the entire United States at some scale.
Yeah,
Now,
Justin sent the link. That's what I'm using right now. I was just wondering if I could get it on a finer scale, I guess.
Yeah, the thing you might check would be Sciencebase. That's our USGS data repository, or it's one of them at least. And there may be maybe higher resolution gravity data sets you can find there.
The thing about data is that USGS or others, the State Geological Survey, they may make available for free some data, but typically, and it works this way with satellite imagery as well. For instance, one of the things that I would like to have is, well, everything that's on Google Earth is free, and it's actually pretty good. I mean, at least in the urban areas, it's pretty high resolution. But what I'm looking for is outcrops, and I want to see it in the winter when the leaves aren't on the trees. So yes, you can get those images as well, but you have to go through a vendor and they're not cheap. So same thing with gravity, same thing with magnetics, is that almost everything is available. Well, I won't say almost, I don't know, but things are available in higher resolution, but those are the ones you have to pay for.
Yeah. Yep. And I know when you were talking about QA/QCing elevation data, I know it's also really coarse, but Google Earth does that to a certain extent. You can get in a ballpark.
Yeah, you can also do it. USGS has an API, so you can send the XY coordinates to it and then pull it back. Google Maps also has an API that you can do, but you got to pay for that. So
the DEMs are the data that you get from the government are in meters. And so if you're working in feet, you have to convert the grid, and there's a utility in QGIS that I couldn't get to work, but it's supposed to be able to take a DEM and convert it to feet. And then once it's in feet, you can do it visually, but the way to do it would be with a formula. And so if you have a bunch of ground elevations from wells or KVs from wells, and you wanted to compare those against the DEM value at that point, I'm sure there's an automated way to do that. The only thing that left me baffled, and I played around with this a little bit, the only thing that left me baffled was I checked of my wells that had ground levels, and I got these from the Oklahoma Geological Survey. They had ground levels, and I checked them against the topographic maps, and they were spot on. They were just perfect. I checked them against the DEM, and they didn't agree. I mean, they weren't. Some of them were off 20 feet, and so there's DEM and there's DEM. There's low resolution and high resolution, and it could be again that the stuff that you're getting maybe has bigger error bars on it than if you want the. And I don't know what the smallest resolution of DEMs are, but maybe the stuff you're getting for free just isn't enough to do that kind of QA/QC exercise.
anybody want to paste that in, I just put it in the chat. That's actually a function that will do that. If you give it X and Y coordinates, it'll return the Z axis from the USGS.
And I put it in the chat window also when John, you were talking about georeferencing in QGIS. And once you do that and you export your image, it's a georeferenced image. So at that point, whatever mapping software, I mean, when you're using geographics, I use geographics, and you're trying to determine how to import an image, you're forced to do an XY estimation ratio between where the XY is on the image versus the XY on the base map. And then you're supposed to sort of derive the rotation angle as well as the skew and the stretch, which I'm sure you could probably put together a spreadsheet that would allow you to do that. But it is a million times easier just to put it into QGIS, pick the points, have it automatically reference, and then flip it over into a georeference TIFF or JPEG, and then import it from there. I mean, that takes at most 5 minutes.
I'm really impressed with the georeferencing. Now, I have had some problems with it, but when I get what I want to get out of it, I'm really impressed with it. The other thing that it has, there's another widget in QGIS that if it's not exactly spot on to your control points, you can manually squeeze it. I mean, it allows you to shift it, to squeeze it, to adjust it, and then you get it even closer to whatever grid that whatever culture grid that you're working off of. So we used to, and I'm reminiscing here, but I never did georeferencing in geographics, but we used a piece of software that we bought that did an okay job, and I used it, and I won't throw out any names. In fact, I don't remember the name of it, but it did an okay job. But this one that's in QGIS, when it works, is the best I've used.
So I just want to jump in real quick. I've been scrolling through the chat, and one person had a question that I thought was kind of important. So if you're using freeware, how do you, what's the typical protocol? Maybe this is a good question for Matthew, for recognizing the people who created the tool that you're using. Like, I guess, for example, if you're trying to publish your work.
First thing you need to check is the license and the license type, because some of them prohibit commercial use, and they have licensing agreements for that kind of stuff. But check the license on it. And then the other thing is usually they do a publication to an online forum or magazine, and then you can look, and a lot of times they'll have how to cite that work on their GitHub. If not, you can also do like a website citation, but to their GitHub or where they host that stuff or the original site. So I use Google Scholar a lot to do that, to check and see how other people have cited it and try to get it in the correct format for what I'm using. So,
gotcha. And that's probably, maybe it's a good thing for us to address here if people can. The software we've talked about today, what are the licensing limitations like for QGIS? Is it okay to use that as a, I guess, for commercial work? And I think, I don't think there were any limitations on the plot digitizer, but I don't know about GIMP. And with Google, I don't know if they really care, but does anybody know?
Just taking a look right now. It does not look like you need to. So commercial, do you plan on using QGIS in your company or organization, but worry about whether there is commercial support available? Sorry, they talk about contributors, but they don't really talk about. Sorry, guys. All content is licensed under the Creative Commons Attribute Share Alike 3 license. And so that is right here, and I'll put it in the chat. So you're free to share, adapt, and you must give appropriate credit, provide a link to this license, and indicate if changes were made. You can mix, transform, or build on the material. You must distribute under the conditions also in that link. And there's no additional restrictions with legal terms or technological measures that restrict others from doing anything the license permits. So as in regard to QGIS, hopefully that answers your question.
Yeah, I just threw, there's a statement at the bottom of their webpage under support where that's kind of addressed. So
I'm going to return this call. I'll be back in just a second.
all right, does anyone else have any questions, or does anyone know of any other software packages that folks on the call should be aware of that they want to share in the chat or tell us about?
I like Inkscape. We use that a lot. And it also has patterns that you can download from the USGS already made up. I don't know if it's from them or for their maps,
Right.
But so you can draw stuff in that, which is it's pretty nice and useful.
Let's see. All right. It's like we're slowly bleeding participants, but we still got about 56 folks.
I was going to say that one of the things that I always needed and made a lot of were cross sections. And I was kind of hoping that with this Albion plugin, that would allow me to make some nice professional looking cross sections off the map, kind of like what I used to do in geographics. And as it is, the fallback to that is using something like Adobe Illustrator. GIMP, I would be a bit concerned because you're creating a huge raster canvas to put logs in, assuming that the cross section is fairly long. So you've got an entire rasterized area, which you can do it if you have a super gaming computer, but not everybody does. Illustrator, which is not free, or Inkscape, which is, or PowerPoint, which is almost, it's not free, but it's, you can make cross sections in it. But again, you're not in a depth registered world in that. You're making a graphic product, which there's nothing wrong with that. But it just takes more time.
Yeah, in years past, I've gone through and made a framework in Excel and then snipped it and brought it over. And so I had tie points in PowerPoint.
And that would work with Google if you didn't want to pay for the MS Office 360. That would work with Sheets too, I'm assuming. I mean, the main catch here is a lot of these things are converting over to a subscription base where, you're looking at an annual renewal. And unless you have that financial support that allows you to continuously renew it and can justify that expenditure, I mean, you might get to a point where, that's something that you're going to do, but I don't know.
So someone shared, looks like Siva shared a link to ParaView, which looks very interesting. Hadn't heard of that one. Let's see. James has shared some NIH stuff. Oh, I thought that said image J. Oh, no, it is. Okay. Yeah, we use that a lot for our SEM interpretation. There's a bunch of different scripts our mineralogists play around with in that.
Yeah, I've done some grayscale analysis in Arbrera with that too. It worked out pretty good.
So there's another question about QGIS that just popped up. It says, would you say that QGIS is the best free software for making isopac structure maps. Um, yeah, hands down, actually. Now, Saga, however you pronounce the acronym, can do that. GRASS can certainly do that. But both of those are incorporated in QGIS, and I don't know if they've rigged it this way or not, but the only one that I could really get to work for me on my kind of data was this GDAL gridding, inverse distance weighting routine. So you may have 10 different gridding options on it, but at the end of the day, not to use that trite phrase, but maybe only one or two of them work. But having said that, there aren't a lot of options, and gridding and contouring is the thing that when you leave your comfort zone of the government or a big company that provides all of your software needs at great expense, and you want to know, well, how do I do this on my own? The options are limited. But having said that, I don't feel that using QGIS is necessarily a step down. It makes great looking maps, and they look every bit as good as, you know, what the proprietary vendors sell. You can't do faulted surfaces. You're not working in voxel space like you are in a 3D program like Petrel, but it just all depends what your needs are. Mine were pretty simple: maps, cross sections, tables, data analysis, and I do wish it had. I wish it had a petrophysical. I wish I had a petrophysical model. And if anybody's got a good option for that, I'd like to know about it. Seismic is taken care of because we've got Open Detect, and I'd like to see a presentation on that sometime. And if we could get QGIS to interface with Open Detect, that'd be great.
And just for putting it on the record, I'm going to put the Open Detect link on the in the chat window.
Somebody wanted me to pick QGIS, Petra, or Geographics, and I've used all of them. And I don't mean to give you a depends answer, but it does depend. I mean, if you really have need for something that Geographics does or Petra does, that like, for instance, handling a faulted surface, then I won't say run out and buy it. I would try to make, given the price of QGIS, which is free, I think I would generate a grid and contour set and manually put in the faults. So, I mean, and you know, but that's just me. It's, you know, it's a whole different game when somebody else isn't paying for these very expensive software programs.
Well, I think the USGS publishes a lot of fault maps, and so if you you can georeference those images and pull them off of out of USGS pubs or websites. I mean, they're not necessarily comprehensive, but they can be a good start, and then you can at least have a quickie way to get a nice image imported.
Yeah. Well, you know, the trick with faults is faults have an attitude, and I don't mean like a bad attitude, but you know, they're on an angle, and you know, so if you see a fault map, well, what's that relative to? Is it relative to this formation or the one 1,000 feet above it? Because it's going to be in a different place, and that probably explains that fault layer, that comprehensive fault layer that I got from the Geological Survey, that kind of shows the same fault moving around. And it's the same fault that's been mapped 5 times by different people, cutting different horizons.
Yeah, that's a good point.
I'll give you one caveat about QGIS is I mentioned there's a learning curve, and I don't know if there are bugs or what. It does crash. It doesn't lock up so much, but it just closes sometimes, and it doesn't have an autosave feature. It does help if you remember to autosave your projects, and you know, we've all kind of been, you know, if you've been in the software game 10 or more years, you remember how awful commercial software was because it kept freezing and crashing and so forth. And I will say that kind of like that software, if you stick to the program and don't do anything too creative, like changing projections and then hoping everything is going to be okay with your shape files, you probably won't have as many problems as you do if you start messing around with it. So part of it is the user. They warn you in the Python plugins. They grade them. They say if they're experimental, and there is a community of people that you know, that comment on whether or not things work or don't work, and and sometimes things don't work at all when they go from version 2 to version 3. And Albion doesn't work anymore. So that's always kind of whatever version you start in, you're kind of married to that version. I mean, unless you know, and because certain things in there just may not translate over to the next generation of software.
Yeah, it's good to know. Yeah, you see, whenever I have software updates, we're sort of required to get them, and occasionally things stop working. But I could see with open source stuff, no one's really got they're not required to make things backward compatible, right? So.
Yeah, that's addressed in the Python world with an environment, or something that's called an environment. You set up an environment that operates in all the dependencies for whatever package you're using at the time it was written in. You use just that. So usually you have your base installation and then several installations of Python separate. So it adds a version control for its dependencies. So
That's handy.
Yeah.
Well, it looks like I'm not seeing any additional questions in the chat. Does anybody have anything else they want to share? We have a few minutes left, so might as well use the time while we've got it.
I did want to say with QGIS, there's a stable, I can't remember, the one I'm using right now. They're named after the country in which they're issued. Is that right, John?
That's my understanding. And yeah, that's my understanding. The development, I pull up the page here. I won't share my screen for this, but I can tell you the countries that are involved are primarily, let's see here, Switzerland, Germany, Spain, UK, Netherlands. Russia's in there as a contributor, but not too much in Asia. And these are the people who are supporting the program. And Western Hemisphere is a desert. I mean, I think there was one American program, one American company or entity that was supporting it, and they've come and gone. Nothing to South America that I found. Mexico, nothing. Canada, there was one.
But
so,
you can find like what's called the long-term release verse, and that's where that's La Coruña.
Yeah.
And that's the one I'm using right now, and that I think is the most stable.
Yeah, that's the one. Let's see here what I've got. Yeah, A Coruña. And that is stable. And I did the one that they recommended upgrading to, and I found that some of my important toolbox plugins were no longer there in the upgraded version. So, which is not to say that they won't be eventually, but I'm trying to get some work done, and I can't wait around for the developers to make new plugins for a new version of the software. So
What I'm putting in the chat window right now is a GitHub link to what's called the QGIS Open Day. And that's where you can discuss in a virtual event sort of what's going on with the QGIS platform, make recommendations for updates, and that kind of thing.
Yeah.
So if you want to learn more workflow stuff, click on that link.
Now, I think for somebody who's handy in Python, the real romance in QGIS is that if Windows can't open a SegWi file directly, you can write a script that'll get you from QGIS to OpenDetect or whatever your desktop interpretation program. And the same may go for petrophysical interpretation. Any kind of non-standard file type that would need a more complex path in order to open directly in one of these specialized geoscience programs. But in my mind, it's doable. It's all doable. I was happy that you could open, for instance, a well. You might want to, for instance, you know how you click on a well and you can produce a well log. You get a whole list of links on it if you set it up that way. And you can produce a well log, you can produce drilling and completion, you can produce all the state forms if you want to keep copies of those. All it takes is time and effort to be able to catalog all that stuff in that kind of a system. It would have to be very important for you to put all that stuff in there. And you know, maybe an organization that has lots of users, it would be worth their while to do that. To me, it's if there's one well or one locality that I really would like to have the log handy for it instead of having to search for it. That would be the way, that would be a good use of that.
Right. Well, if there's nothing else, guys, I think we can call this a webinar. And
Sounds good. Well, thank you for attending and thank you all for presenting.
Thanks for organizing, Mike.
Yeah, I'm just, I've got a lot of things to look at. I thought I had a lot before. Thanks a lot for the contributions, not just to the presenters, but also to the participants. There's quite a bit here in the chat box. So I'm going to save the chat. I'm going to save the talk itself, and I'll distribute it first to the presenters, and then whoever wants it or whoever, you know, just take a copy and send it out.
yeah, it might be easier just to post it on the YouTube site and distribute that link. And then, like I said, we could talk about following up with a list of, you know, some of the links that we shared during the talks.
Yeah, and if you like it on YouTube and you want to get a copy, then there's a link for GitHub for a, I don't know what that is, YouTube recorder. Anyway, we were talking about potentially having a free data for freelancers that might be coming in the future. We'll just talk about it some more. And otherwise, thank you for attending. And we'll call that a wrap.